we're going to use patterns in calculations to try to describe the pattern in general using a variable. That's the objective for today's lesson. So here we go. Jason's going to a dance. It's $8 to get in. Each soft drink is $1.25. So we're going to calculate the amount of money Jason might need depending on how many drinks he buys. So to start out with, he has to get in. So that's $8 plus $1.25 per 0 drinks. So that still comes out to be $8. If he buys one, then there's the cost to get in, and it's $1.25 times 1 drink. So it's $1.25 and 8, which is $9.25. Then, if he buys 2 drinks, it's still $8 to get in, and it's $1.25 times 2, which is $2.50 onto 8. That's $10.50. So if he buys 3 drinks, it's a standard $8 to get in and the $25 per drink. So it's 3 times 125, which is $3.75. If you add that onto 8, you get $11.75. So we're just going to keep going. 4, 125 times 4 is $5. So 8 plus 5 is $13. So let's bump it up a little bit. What happens if he buys 10 drinks? Meet some friends there, decides that he's going to buy something for them. So that would be 125 times 10. So 10 times 125 is $12.50 plus $8 is $20.50. Okay? So what happens, what are we going to do if it's D, the number of drinks? If we look at the pattern, Jason's always going to pay $8 to get in and $1.25, and then the 0, 1, 2, 3, 4, and 10 are all the number of drinks that he would buy. So it would be times D. So the overall expression for the amount of money he needs is 8 plus 1.25 D. Okay? So here's another example. It's about food. Okay? And it involves calorie in food, and it's your basic, food stuff may have fat, protein, and carbohydrates. 9 calories per gram of fat, 4 per gram of protein, and 4 per gram of carbs. So if this small little piece of thing has a gram of fat, a gram of protein, and 5 grams of carbs, it works out like this. 9 times 1 plus 4 times 1 plus 4 times 5. The question is, what is that total? So that's 9 and 4 is 13, and 20 would be 33 calories total for that. So what if it had different components in there? 1 gram of fat, 3 grams of protein, 2 grams of carbs. So that's still going to be 9 times 1 plus 4 times 3 plus 4 times 2. Okay? So 9 plus 12 is 21, plus 8 is 29. So that one actually has a few less calories in it. What happens if it's even distribution of grams of fat, protein, and carbs? So that would be 9 times 2 plus 4 times 2 plus 4 times 2. So that's 18, and 8 is 26, and 8 is 34. Okay? So none of those will get anybody alarmed, but what happens if you eat something that has 10 grams of fat, 5 grams of protein, and 11 grams of carbs? That's going to be 9 times 10 plus 4 times 5 plus 4 times 11. This is a little different. This is 90 plus, that's 90, plus 20 is 110, plus 44 is 154 calories in that. So how do we write this expression in general? That would be, so let's use some letters to represent the amount of fat. So I'm going to call it F and P and C for fat, protein, and carbs. So our variable expression is 9 times, and this is where the number of grams of fat comes from, plus 4 times the number of grams of protein, plus 4 times the number of grams of carbs. So overall, that would look like 9F plus 4P plus 4C. That's the general idea for what I want you to be working on today. I hope this is helpful. If not, there are a couple other examples in your book in section 2.1. I'd like you to take a look at those as well. Your assignment in the book is 1 to 8, I believe. Yes, do problems 1 to 8 in the book. Thank you.